The points A, B, C, D, it's minus 5, 14, 1, 2, 5, 4 and 3, 8 respectively. Show that AB and CD are parallel. Find the equation of AB. The line L passes through the point D and is perpendicular to AB. Show that L has equation x minus 2y plus 13 equals 0. The lines L and AB intersect at the point E. Find the coordinates of E. Calculate the length of EF, where F denotes the midpoint of AB. So there's a lot to take in, so I've summarised it all here in the question then. Here's our 4 points. Let's do part 1 of A. Show that AB and CD are parallel. So gradient AB and gradient CD then. So here, so A part 1 then. The gradient of AB is equal to, it's the increase in y, so A to B 2 take 14, 2 take away 14 is minus 12, over 1 take away minus 5 is 1 plus 5 is 6, which equals minus 2. And the gradient of CD then, let's see what that is, C to D, 8 minus 4 is 4, and then we've got 3 take away 5 is minus 2, so that also equals minus 2. Okay, so they are parallel, so lines are parallel. Part 2, find equation AB. So AB are these points here. So the equation AB, we know the gradient, and we know it goes through 1, 2. So we can just simply use the point B, 1, 2, don't we? Can't we? So part 2. So it would be y minus the value 2, because of the coordinates 1, 2 that the line goes through, is equal to the gradient of AB, which is minus 2, x minus the 1, because it went through the point 1, 2, didn't it? So there's our equation then of AB. Part 3, L passes through D and is perpendicular to AB. So D is the point 38. So D is 38. Let's just write that down because we need that. And also we need part 3, don't we? Perpendicular to AB. L has gradient then. It's perpendicular to AB, and AB has gradient minus 2, so the gradient is going to be a half, because a half times minus 2 gives the product of minus 1, which is the product of perpendicularity of gradients. So there's the gradient then. Here's the point it goes through. This is the line, so we've got y minus the y value is equal to the gradient, half, times x minus the x value, which is 3. So now move the 2 up to be 2 times all this, so it's 2y minus 16 is equal to x minus 3, and now we can move everything over to one side, can't we? So we end up with then x is there, move the 2y over to minus 2y, and then move the 16 over to plus 16, take 3 is plus 13 equals 0. And that's what we wanted to show, wasn't it, here? L, so that's, and AB intersect at E. So where was AB? Here was AB, part 2, and this is the line L. So this is the line L. This is the line AB, wasn't it? Just to remind ourselves. They intersect at E. So let's find the coordinates then. So this is part B. E has coordinates. So where these two lines intersect then? So y minus 2 equals minus, so let's write this in. Okay, how are we going to do this then? We could do 2y here, double all this. We could do that, put that in there, we could do that. Just thinking now. Well, let's do that then. Let's have 2y here. So 2y, double this, is equal to minus 4x, and then plus 2, which will be plus 4, because I've doubled these. And I'm going to move this over at the same time, and that's going to be plus another 4. So it's minus 4x plus 8. Now we can sub that in. This is equation 1, say. This can be number 2. So what do we get then? X minus 2y, which is minus all this, so that will be plus, run the minus through this. X plus 4x minus 8 is plus the 13 equals 0. So what do we get for x then? We get 5x plus 5, so move the plus 5 to minus 5. And that tells us then that x is minus 1, isn't it, when we move the 5 from times to divide. So there's x for the coordinate of e, and then y, we can get y from here, say. Also, we can get y from here actually. Y is equal to 2, move the 2 over, and then it's minus 2x minus 1, which equals 2 minus 2 times minus 2. Minus 1 in here, that's minus 2 times 2. So that will be plus 2 times 2 then, won't it? Which is 4 and 2 is 6. So y is 6. So E has coordinates then, which we've done. E has coordinates, so E has coordinates minus 1 and 6. So that was B part 1 then. Now B part 2. So let's just flick back up here. Calculate the length EF, where F is the midpoint of AB. So AB are these coordinates here. So let's just copy them. And then we can drag them down. Let's take AB. And then we'll move them down. So we've got them here. As we drag them down. And we'll just move them down. So what was it now? F is the midpoint of AB, and calculate the length EF. So this is part 2. So F has coordinates then, add them. 1 and minus 5 is minus 4, divide by 2 is minus 2. 14 and 2 is 16, divide by 2 is 8. 16 over 2 is 8. So there's F. E has these coordinates, so the length EF then, the modulus, the distance between E and F, that's what the question asked us for. It's the last part of the problem. Okay, so let's have a go at it then. So it's just using Pythag. Minus 1 to minus 2 is a distance of 1 unit difference, so it's 1 squared. And then 6 to 8 is a difference of 2 squared, isn't it? So we get root 5 using Pythag, 2 sides of a triangle.